Fine. So this is your topology. It's very simple. I'm having only 4 routers, and usually in this topology I'll be performing practicals in perspective of lane networks of R3 or lane networks of R1 only. So let's start it from R1 router EIGRP. Now we have 2 options. One is directly AS number, one is with the help of name. So we can use here we can configure EIGRP in classic mode as well as in named mode. So if you want to configure EIGRP named mode, let's say you want to allocate its name as CCIE, then after you do not have any other option. Now you can ask me that, okay, what is the advantage of having this named mode EIGRP? See, very first advantage of having this named mode EIGRP is, like, here we can create now address families in a single process. Actually this name is what? It's a process of EIGRP now. Now within this process we can run some sub processes. One is for IPv4, and along with that we can also run another process for IPv6. In this way, like address family, if we are running IPv4, then I'll be saying IPv4, and if I am using IPv6, you see I'm having these 2 options available over here. So within this process now I can run EIGRP for IPv4 as well as IPv6. So by running a single process of EIGRP, I can use EIGRP for IPv4 as well as for IPv6. I will not require, see, if you take an example of classic mode, and if you are running IPv4 and IPv6 simultaneously, like in dual stacking mode, you will require to configure multiple processes of EIGRP, because previously your command was something like this, like router EIGRP 100. That's fine, that will work only for IPv4. If you want to configure EIGRP for IPv6, then the command was IPv6 router EIGRP and another process. So you will you are required to configure multiple ASs, multiple processes of EIGRP to configure it for IPv4 and IPv6. But after launching this named mode EIGRP, like router EIGRP as I2CCIE, you can take address family IPv4, and then it will ask for your autonomous system number, right? So autonomous system, let's say it is for, it is 100 for IPv4. So it is for IPv4. Fine. Within this address family, now you will be doing all configuration of EIGRP. Like if you wanna use network command, use it. If you wanna configure authentication, configure it. If you wanna configure summarization, do it. If you wanna perform route filtering, perform it. You wanna create default route in EIGRP, of course you can do it from here. Whatever you will require to configure in EIGRP, you will be doing that configuration within address family. Here in named mode, you will be doing everything related to EIGRP within address family only. Previously, to configure authentication, to configure summarization, it was necessary to move under interface mode. Commands were required to configure under interface mode. But here in named mode, you will never ever required to change your mode. Within address family, you can do everything. At single point, you are having everything now. Similarly, you could run address family for IPv6. What is it saying? IPv6 unicast routing. Just enable that. Router EIGRP CCIE address family IPv6 autonomous system 100. See, I'm using same AS for IPv4 as well as IPv6. This is the major advantage of having named mode. Right? But this time here we are not going to implement it for IPv6. We will be implementing it only for IPv4. So let's configure it for IPv4. Address family IPv4 autonomous system is 100. Fine. If you wanna enable EIGRP onto some interfaces, do one thing, say network, right? And we want it to enable it 12.1.1, and then we can take wildcard mask as this, the network 14.1.1, and then we can say network 10.1.0.0.0.0.7.245. You will see that EIGRP will get enabled onto all interfaces of this device, router 1. Fine. Exit. Show IP EIGRP interfaces. Check it out. Done. So EIGRP has been configured here onto all devices. EIGRP has enabled onto all interfaces, onto all interfaces of this device. Similarly, I'll enable EIGRP onto our router EIGRP. It's not mandatory to use same name, similar name on all devices. It's not mandatory, but it will be good if you use same for administrative purpose, right? Because you will remember, okay, that you configured PCIe onto all devices, so you can. Otherwise, every time you will require to check your name first, and then after you can move into EIGRP, right? So now you can set assembly IPv4 autonomous system, and again in named mode 2, your AS number must match. Otherwise, neighborship will not come up. Say network 12.1.2, network 23.1.2. Fine, that's fine. See, EIGRP neighborship has came up now. Show IP EIGRP interface. Check it out. Fast Ethernet 0/0 and fast Ethernet 0/1. Network 23.1.3. And done. Similarly, on R4, done. It has formed neighborship, both of them. Now let's start it from R1. Show IP EIGRP neighbor. Just check it out. Neighborship has came up successfully now. Show IP route. We must have all routes available in its routing table. Yes, for per-prefix it is performing equal cost load balancing, because you can look at the topology. Of course, R1 will perform equal cost load balancing for the lane networks of R3. Similarly, R3 will also perform load balancing for the lane networks of, you see. Fine, let's move back again on R1. If I'll start it from basics once again, I'll tell you that how to change allow interval, hold down timer, how to configure authentication, how to configure summarization in named mode, right? And then after we will go for some advanced practicals. So let's say that I want to change hello interval onto R1. By default, what's that actually? Check it out. Show IP EIGRP interfaces detail. So by default, you can look at fast Ethernet 0/0. Hello interval is, and in this iOS it will also show you. In older iOS's, like in iOS 12.4, it never shown this hold down timer in the output of this command. But here in iOS 15, it will always show you this hold down timer as well, right? So this is the hello interval by default. This is the hold down timer. Split horizon is by default enabled. All these things, right? Hello sent and expedite. It's fine. Authentication mode is not. So this kind of information you will get it over here in the output of this command. After it, you can also configure this command show IP protocol. Here it will show you that, okay, what are you using, like EIGRP 100 is there, and K1, K2, 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 K3, K4, K5, K6. I told you that in named mode it will be using all 6K values. So K1 and K3 are 1, rest of them are zeros. 64-bit, as I told you before. router ID is there. If you use older iOS version, it will never show you this router ID in the output of show IP protocol command. Active timer, well, it will never show you in older iOS, but here it will show you. Variance is same as previously. Total prefix count, see, total number of prefixes having in its routing table. It was not available before, but now it is having that. Then automatic summarization is by default. In older iOS's, it was by default enabled. Fine, AD value same as previously. Let's make some changes. Start with timers, that how can we modify hello interval and open timer. Previously, like if we take an example of older iOS, we were moving under interface mode and then we were saying like IP hold time EIGRP 100 and then hello interval. But now this command will not take place. Even you can try it. It's not going to take place. Let me show you. Show IP EIGRP interfaces on FA0 by 0. It is still. So whatever you will be doing under interface mode in named mode, it will never take place. Never ever. So if you wanna do something like this, then you have to move under address family first. Autonomous system works. Let's say that you wanna change timer of an interface. So there is a command AF interface. Address family interface, and then go to your interface. If you wanna change hello interval on all interfaces, I get my point. If you wanna change your hello interval on all interfaces of this device, then say now change your hello interval. Changes will take place on all interfaces of this device where EIGRP is enabled. So this time I just wanted to enable it onto all fast Ethernet 0 by 0. So I took fast Ethernet 0 by 0 and then I'll be saying there is nothing like type IP hello time hello interval EIGRP and all. I mean, like it was long command, right? Now you just need to type hello interval and then your timer. Let's say it is 10 seconds. Done. You don't need to type that much long command now. They have simplified it now. You don't need to change your mode. You are still under address family and you can modify whatever you want in EIGRP. Now your changes have taken place. You can verify it. Show IP EIGRP interface detail. Router EIGRP CCIE address family IPv4 autonomous system. Let's say I want to configure some interfaces as passive interface. It's very simple. AF interface default passive interface. Done. All interfaces will become passive interface within address family. Everything, whatever you configured in router mode, whatever you configured under interface mode over there in classic mode, you will be doing it now within address family. Fine, passive interface. Just come outside. Now I know very well that I have to send hello packets out from FA0 by 0. So I'll be saying AF interface fast Ethernet 0 by 0 no. Say similarly AF interface fast Ethernet 0 by 1 say no. Passive interface. That's very simple. So this is how you can configure passive interface in named mode EIGRP. Fine. Apart from it, authentication. Same. If you want to configure authentication on all interfaces, then say once again AF interface default authentication. So authentication will get enabled onto all interfaces. But let's say that I want to configure authentication only for R1. I'll be saying AF interface fast Ethernet 0/0. Say authentication mod. You don't need to specify IP, authentication, EIGRP, AS number, and everything. No, you just need to say authentication mode. MD5 we already done. Now it supports more secure authentication type, that is SHA. So SHA, sorry, HMAC SHA 256. Encrypt password. Let's say that you want to configure Cisco at 123. That's it. You don't need to even define keychain if you are using SHA. In MD5 still you will require to configure your keychain. Like if you say authentication mod MD5, then it will ask for, then after you will require to define your keychain. Like you will be saying authentication keychain. But this time because we used SHA HMAC, so we are not required to create any keychain. We are also having one disadvantage of using this HMAC SHA, like we will not be able to change our keys after a period. Like in keychain we could define multiple keys, rotational keys, but here you cannot configure rotational keys if you are using HMAC, and even it is not required here. You know why? It is much secure because it's not using SHA alone. Along with SHA, it is also using HMAC, and this HMAC is very, very strong algorithm. This HMAC is actually hash message authentication code, and this is really secure protocol, and it always works with SHA or MD5. This time it is used with SHA. So here you will not require to change your keys, or you will not require to define your rotational keys. Fine, that's done. So this is that how we configured authentication in named mode EIGRP. Now neighborship has gone down. You can look at this debug EIGRP packets. It will show you that hellos are coming from there, but you see missing authentication. I'll move back onto R2. Similarly, router EIGRP, CCIE, address family IPv4, autonomous system 100. AF interface, fast Ethernet 0/0, because onto R2 I'm using after 0/0. Similarly, I'll say authentication mode HMAC SHA. Then it will ask for password, that was Cisco at 12. Now neighborship must come out. Any problem in authentication? Done. After it, let's go for summarization. So if you want to configure summarization, if you want to disable split horizon, I'll be doing all these things at the same time, right? So let's say that for our network, I want to configure this path as a primary path to reach all 10 prefixes. I want to configure this path as a primary path for all these routers like R2, R4 and R3. So all of them must reach this R1 by R4 only. I can configure summary address over here so that it will be advertised on /21, and via F0/1 it will keep on to advertise prefix on /24. So based on longest prefix match, this path will become primary path. So let's do it now. So on to R1, I'm gonna to configure summarization. Once again, router EIGRP, CCIE, address family IPv4, autonomous system 100. AF interface, I want to configure it on FA0/0. Then I'll be saying summary address, and now your summary address. It's very simple. Under interface mode, summary address 10.1.0.0 245.248.0. Enter. They have simplified your commands actually. You don't need to specify that much long command IP summary address, EIGRP, AS number, that summary address. Yes, after that you have all other options available, like you can define your leak map. Same as older iOS versions. but there is no option of changing its AD value. Previously it was possible to change AD value, right? Now it will remain as 5. So now you can see that if I trace route distance prefix, like trace route and .1.1, is not it. It is going via R3, R4 and then finally R1. That's what we wanted. So in this way you can configure summarization. Apart from it, let's remove it now. This time, R1 is performing equal cost load balancing for all 30 prefixes. You can look at this. I don't want to let it perform equal cost load balancing. Let's say this is my primary path, right? This is my primary path to reach 30 prefix from R1. So what can I do? I can either decrease bandwidth of this interface or I can increase its delay. Let's do one thing onto R1 itself. I'll be doing one thing, interface like yes, do show interface fastest net 0 by 1. By default its delay should be 100 microseconds. I'll make it 1000 microseconds. So interface of 0 by 1, delay 100, because it will always be configured in the multiple of 10. So now you will see that R1's best path to reach all 30's prefix will be via R2, but it will still keep all those prefixes in its topology table as a feasible successor. So EIGRP topology. All these prefix, this path is my feasible successor. Now I want to perform unequal cost load balancing. We can configure an equal cost load balancing with the help of variance. You understand? So I want to perform unequal cost load balancing for 30 prefixes. Of course I can do that. Show IP protocol. You see by default it's, you want to change it. To change variance there is a command topology base. Remember that in older iOS's, whatever you configured in router mode, to do that configuration you will always require to move into topology base. Once you will move in topology base, now here you can configure all those commands which you configured in router mode in earlier versions. Now let's say X2. Here you can find all those commands. See, default information, default metric, distance, distribute list to perform route filtering, right? Maximum path, offset list, redistribution, summary metric, traffic share, variance, everything. So all these commands will be configured within topology base. Just come outside, you can look at the output of IP protocol. Even it will show you here all these things under topology base itself. So this time its variance is 2. Show IP route. It's not sufficient. It's not sufficient actually. We have to make it like 4 times. Router EIGRP. That was CCIE at assembly IPv4 autonomous system 100. Topology base. I can make it directly now 120. This is not topology table now. This is routing table. So in this way you can perform all these practicals. Apart from it, if you want to change your active timer, now you understand very well that what is the uses of active timer in EIGRP, right? So if you want to change that, like here you can see by default your active timer is 3 minutes. To change it, it's very simple. Topology and timer, active time. It's up to you that what do you want to do configure. There is any problem, please let me know in named mode. Fine. Now once again topology base, I will say variance is 1. Done. Now I'll teach you advanced feature of EIGRP that was introduced in named mode only. See, this time I'm on R1. Type it out. Best path to reach 30's prefix is via. So every time whenever it will go towards 30.1.1, it will go via R2 because its best path is via R2. Fine. So IP route 30.1.0. Does it have any other information in its routing table that it can also reach this 30's prefix via any other neighbor? Is there any information in its routing table? Of course no, because I used this command so IP route, so there is no other information available. However, it is having feasible successor. I can show you that. So IP EIGRP topology 30.1.0. See, via 14.1.4, but it is what? Feasible successor. So you know very well that by default EIGRP does not install feasible successors information in its routing table. Now, so IP SAP 30.1.0. Check it out. Is there any other information? It knows. It's just how this information in its routing, SAP table. Like to reach this prefix, next hop is 12.1.2 and exit interface is fast Ethernet 0 band. That's the only information available in its SAP table, FIB as well as RIB. Fine. Now there is a problem. In case if your successor goes down, it will be removed from its FIB table. It will take some time, to define feasible successor as a next successor, and then it will install that successor, that new successor into its RIB, and then it will get copied from RIB into FIB. During that period, right? During that period, of course, there will be some outage in the network during this failover. Just to reduce this outage, we are having an option in EIGRP that is FRR, fast reroute. I'm going to use that FRR now in EIGRP. So, but remember that for FRR, it is mandatory to have feasible successor. Fast reroute. Router EIGRP, CCIE, address family IPv4 autonomous system 100. Topology base. Fast reroute. We have some options. Per prefix, of course, we want to enable it per prefix. For all prefixes which are available, for which it is having feasible successor, or for some specific prefixes. If you want to enable this feature for all prefixes, select. If you want to do it only for some specific prefixes, then you have an option of configuring route map. In route map, you will permit only those prefixes for which you want to enable FRR feature, fast reroute feature. Just enable this feature now. In actual routing table, still it will be having only one path. I mean, if you look at the output of show IP route, but if you look show IP route, I mean, if you look at the detailed information about the prefix, in routing table itself, it has installed its feasible successor now. However, it is not going to perform equal cost load balancing or unequal cost load balancing because it is working as a repair path. Previously, it was not showing me this repair path, right? Without enabling FRR. In same way, show IP SAF. This is the advanced feature that they introduced. Exactly. नहीं. This is not PFR. FRR. Yes. In named mode. हाँ. यार कर लेना खुद ही अब तुम इसको. Make sure that your interface is going down from the end of R1. And if you wanna see actual impact of this feature of EIGRP, for this it is mandatory to enable BFD. BFD, bidirectional forwarding detection. That feature must be enabled in your network. Because this time this repair path can work in that case only if your interface is going down from the end of R1 only. What if in case this end has gone down? Then again R1 has to wait for next 15 seconds for breaking up its neighborship. But if you have enabled BFD, bidirectional forwarding detection, within milliseconds, like within 150 milliseconds, it can come to know that this link has gone down, and BFD can directly inform to EIGRP. So EIGRP will immediately break its neighborship, and then it will start using its backup path. And if I enable BFD now here in between R1 and R2, R1 and R2, both of them will stop doing work. I mean, like if I enable this BFD feature here, it is possible to enable BFD feature. I can do that, but routers will not respond that. BFD यार मतलब virtual router है finally. इसके लिए थोड़ा CPU heavy चाहिए होता है. Like interface fast Ethernet 0x0 BFD, and then you can see interval. This is the command to enable BFD. Let's say minimum multiplier. That's fine. With using this command, we can enable BFD. I'll teach you BFD as well. That what is the role of BFD in network? How can we enable it? After enabling BFD, you will see we will integrate this BFD along with EIGRP with using this command router EIGRP CCIE address family IP v4 autonomous system 100 topology base. Oh, sorry. Then let's say that I want to enable BFD on its interface fast Ethernet 0x0. Then I can say BFD. That's it. So for EIGRP, BFD will get enabled for this interface. So first of all, you have to enable BFD onto interfaces, and then after integrate your BFD along with your EIGRP. So that if BFD find any outage in your network, like link has gone down, visibility has gone down, then BFD will immediately inform to EIGRP. So remember that wherever you will find this FRR, fast reroute, and you will definitely find this BFD configured, and in all production networks definitely you will find this BFD enabled, especially in telecom networks. क्या 50 क्या BFD का? हाँ क्या बताया था? टाइम. अब टाइम पे क्या करोगे उसमें? कब? अगर हम FRR यूज नहीं कर रहे हैं,
अगर मेरा सक्सेसर डाउन हो गया तो फिजिकल सक्सेसर 15 सेकंड लेगा.
नहीं 15 सेकंड नहीं लेगा यार, थोड़ा मतलब कुछ मिली सेकेंड्स लेगा, 15 सेकंड नहीं लेगा. इन केस इफ सक्सेसर गोज डाउन देन इट विल इमीडिएटली डिफाइन फिजिबल सक्सेसर एज ए. ठीक है, तो I don't think so that now you will ever get any problem in enabling BFD, and that how, and also you have came to know that how can you integrate BFD with EIGRP. So mainly this FRR feature will be useful in that environment only where you have enabled BFD.
BFD enables the link down, means we can
see let me tell you that how BFD works actually. See, actually this is router 1, right, and this is router 2. This link has gone down. Let's say R1 will come to know that okay, this link has gone down. It will immediately break its neighborship and immediately flush all those prefixes which were coming, which were received from this neighbor. But what about R2? Because at the end of R2, its line protocol will never go down. So it has to wait for next. But meanwhile, there will not be any communication between R1 and R2. So R2 will still keep all those prefixes which were learned from R1 in its routing table for next 15 seconds. So this convergence will be depending on the routing protocol's convergence time, and that is too much. What? कुछ भी नहीं है. Keep alive कुछ नहीं करेगा. Keep alives are exchanged in between switch port and routers interface, not in between router to router. If routers are directly connected without using any a switch or something like that, then definitely if any one of the end goes down, another end will go down automatically. उसमें ज़रूरत ही नहीं है यार, BFD की भी ज़रूरत नहीं है उसमें. अगर ये लिंक आपने शट डाउन कर दिया इमीडिएटली, इधर का तो वैसे ही डाउन हो जाना है, ये पावर ही नहीं जाएगी. So that now it's mandatory actually to enable BFD. So BFD is the protocol actually which will be enabled on both ends actually here in this manner. And now BFD will send some packets in every minimum time interval is 15 milliseconds, right? So you can configure hello interval as 50 milliseconds and hold down interval as like 150 milliseconds. So if it does not receive any response within 150 millisecond from R2, which means that link has gone down. But some extra overhead will definitely be there. Some extra overhead will be there, but to get something you have to lose something.
So if there is a fluctuation in the primary path, that will create, and we have enabled FRR, then that will create a huge problem in that.
हाँ, अगर यहाँ पे फ्लैपिंग हो रही है तो of course it will create a huge problem.
डिसएडवांटेज हो जाता है.
डिसएडवांटेज वो भी तो है ना 15 सेकंड्स का. अगर आप ये एनेबल नहीं करोगे तो 15 सेकंड का बहुत ज़्यादा डिसएडवांटेज है. फ्लैक्चुएशन में एटलीस्ट ही होगा. लेट्स से दैट ओके दिस इंटरफेस इज कमिंग अप, अगेन इट विल बिकम प्राइमरी पाथ. सो ड्यूरिंग that period it will pass your traffic, right? But once again, let's say that again it has gone down, then again your traffic will be going through the secondary path, but at least your traffic will not get dropped. Fluctuation hogi, flapping hogi, routing table will become inconsistent, but still there will not be any huge impact onto your data. होगा थोड़ा बहुत ड्रॉप जरूर आएगा नेटवर्क, वो तो यूटिलाइजेशन बढ़ जाएगा, और दूसरा कुछ ड्रॉपेज मतलब आउटेज भी आएगी थोड़ी बहुत, कुछ पैकेट्स ड्रॉप हो जाएंगे, बिकॉज कई बार क्या होता है कि ठीक है यहाँ से तो इसने पैकेट पुश प्लेस किया इंटरफेस पे, यहाँ पे पहुँचा नहीं था, लेकिन उससे पहले ये डाउन हो गया, तो वो पैकेट तो ड्रॉप है ना, तो कुछ ड्रॉप तो होगा, बट फाइनली इतना कुछ ज़्यादा आउटेजेस मतलब इतना कुछ ज़्यादा ड्रॉप नहीं होगा कि आपके नेटवर्क को इम्पैक्ट करे। हाँ, वॉइस ट्रैफिक को थोड़ा सा यहाँ पे जो वॉइस बेस्ड ट्रैफिक होगा उस पर तो इम्पैक्ट आ जाएगा, बाकी टीसीपी बेस्ड ट्रैफिक होगा उस पर बहुत ज़्यादा इम्पैक्ट नहीं आएगा, वो रिट्रांसमिट हो जाएगा इन केस इफ एनी पैकेट वाज नॉट डिलीवर्ड सक्सेसफुली। So this was, I mean, that was the advanced feature. Then apart from it, if you wanna perform route filtering, let's say 30 prefixes are coming here, you can do that very easily. Again, you can use either standard ACL, extended ACL, route map, prefix list, whatever you wanna use, right? You will be doing it in this manner: CCIE, address family, IP, v4, autonomous system, 100. Topology base. Distribute list will be configured in topology base. I don't think so that I should go for this practical, because now rest of the commands are same, concepts are same, like distribute list, prefix list, test, in. Now you can call your interface as well. Let's say you want to apply it for F0 by 0. Done. If you do not specify your interface, fine, it will be applied for all interfaces for their incoming updates. Understood? So this is the way. Fine. In EIGRP, if you wanna disable a split horizon, go to AF interface, pass Ethernet 0 by 0, say no split. This is the command to disable split horizon in EIGRP named mode. Previously, you know what was the command in older IOSs? Go to physical interface. So no IP split horizon EIGRP AS number. That was the command.
एक्चुअली सर ये सारा पार्ट तो हमने पहले ही कवर कर दिया उसके अंदर, नेम नो ऑटोनॉमस सिस्टम के अंदर ही हो रहा है, तो उसे सारी चीजें पहले पता चल गई।
Exactly. Router EIGRP, CCIE, address family IPv4, autonomous system, 100. AF interface, pass Ethernet 0 by 0, no split horizon. To enable it, split horizon. You can also say next hop self. By default, this command is enabled. If you want to disable this command, you can say in which condition you will be using it. If you are having a hub and spoke topology, let's say you configured it as a hub, and these are spokes. Now you can say, sir, how can we define hub and spoke topology if all routers are interconnected with using a switch? Of course we can do that. You know how? We can configure static neighborship. On to R1 I can define that, okay, my neighborship will be with R2 as well as, but on R2 I can define that my neighborship will be with R1 only. Similarly, on to R3 I can define that my neighborship will be with, so we can define a hub and spoke topology. If we are having hub and spoke topology, I'll be doing it. See, we will perform these practicals during DMVPN. Like whenever we will configure EIGRP over dynamic VPN, in DMVPN we will be configuring hub and spoke topology. At that moment we will see that all branch offices will be connected to their hub, to their headquarters, so that will become a hub and spoke topology. And then you will see that this hub will receive all updates onto this interface only from all spokes. Then if it receive any route from one of these spokes, then it will never forward that same route towards any other spoke due to a split horizon. And if you disable a split horizon, then it will start to exchange routes in between spokes. But again there will be a problem. Like if R1 is receiving a prefix coming from SPOC 1 and forwarding it back towards SPOC 2, it will change its next hop address. Its next hop address will be its own address, right? I mean, it will see, it's not RIP. In RIP, when I disable split horizon, it was not changing its next hop automatically, right? In case of RIP, it was not changing, like route was going through hub, but it was not changing its next hop automatically. But in EIGRP, because next hop stuff, as I told you, is by default enabled. So whenever this, let's say that R2 was having a prefix 20.1.0/24, it given it to R1, then R1 forwarded it towards R3. Now whenever R1 will forward this route towards R3, it will define its next hop address as its own address. Now whenever from the lane of R3, whenever we will try to reach 20's prefix, then traffic, I mean the direction of traffic will be like this. However, traffic should go directly from here to here without traversing hub, because let's say that lane users of SPOCs wanna communicate with each other, then every time your traffic will traverse hub, and if your traffic is traversing your hub, your headquarters, your hub, right, then the bandwidth of this link, you can see what can happen to this link. So to solve this problem, of course, like R2 is having neighborship with R1 only, R3 is having neighborship with R1 only, but this is a multi-axis network, right? So R2 can reach directly R3, but there is no neighborship between them because we didn't configure that. So they exchange their routes via hub only, but we want that traffic should go directly from the lane users of R2 towards lane users of R3. So that can go from R2 to R3 in that case only when that in case if we do some configuration so that whenever R3 will receive this 20's prefix, then in that case its next hop address should be R2's address.
And then it is forwarded to the switch.
Exactly. So for that purpose on R1 I have to say no next hop self. So that whenever R1 will receive any prefix onto this interface, and whenever it will forward that prefix out from the same interface in the direction of another SPOC, it will not change, it will not modify its next hop address. So for that purpose we are having this command like no next hop self. Hope you understood it. Right now you won't be able to understand it, but definitely whenever we will go for DMVPN, then you will understand that why do we have this feature. So during dynamic VPN I will teach you these things once again. I mean I will be configuring all these things. But remember that in older iOS's command was something like this, like under interface mode, say no IP, next hop self, EIGRP, and then AS number. That was the command in older iOS's. But in named mode, go to say fine. Is there any problem now? Done? Fine. After it, there is another topic in EIGRP, that is stub routing. I'm going to perform that stub routing now. First of all, why do we require to configure stub routing in our network, in our domain? See, there was a problem actually that is called stuck inactive, right? And it's not unknown for you. You know very well that what is the meaning by stuck inactive. So due to stuck inactive, might be your routers will keep routes in their routing table unnecessarily for 3 minutes. And then after, due to stuck inactive state itself, they can break their neighborship with their neighbors. And if they break their neighborship with their neighbors, then might be that there will be some brief outages in your network, right? Now to avoid this stuck inactive state, see, we always want to configure EIGRP in such manner so that there will be less possibilities of occurrence of stuck inactive state. We will always design EIGRP in that manner so that there will be less possibilities of occurrence of stuck in active state. So we have to design EIGRP in that manner. Fine. Now if we want that stuck in active state should not occur in our network, we have two solutions for that. Use summarization as much as possible. Use summarization as much as possible. You know why? Let's say there is a router 1. Just try to understand it in this manner only. It's very simple. And here we are having so many networks like 10.1.0, 10.1.2.0, 10.1.3.0. Now you do one thing. Onto this interface configure summary address for all these 10 prefixes so that it will advertise only and only summary address. Now in case if any one of the link goes down, so only one subnet will go down, right? So this R2 is not, R1 is not going to forward this information towards R2 because R1 will still keep on to advertise that summary address towards R2. So R2 will never come to know that, okay, this prefix has gone down. So R2 will never generate any query message. However, there will be one disadvantage too.
R1 send the query message or R2?
No one will send query message now.
No, if we don't summarize it, then who will
Then
send it?
R1 will also generate query message, R2 will also send query message towards its neighbors. Whoever will lost successor will generate query message if they do not have feasible successor. That is the thumb rule for EIGRP.
क्वेरी आखिरी के पास में आएगी ना,
हाँ,
आखिरी के बाद
सबके पास जाएगी सर. Then, so by configuring summarization, we can reduce possibilities of occurrence of stuck in active state. But still, if you configure summarization, there will be some negative, like some problems can occur. Like in case if this network has gone down 10.1.0, but still this router 1 is giving some address to R2, R2 is giving it to R3. Then from the lane just try to think in perspective of lane user of R3. Let's say lane users of R3 wants to reach 10.1.1.1. So because R3 is still having that summary address, right? So it will forward this traffic in the direction of R2. R2 was still having this prefix, this summary address from R1. R2 will forward this traffic to R1, but R1 doesn't have that prefix available in its routing table. So R1 has to drop this traffic. So unnecessarily now traffic is flooded out in the direction of R1. Unnecessarily, however, this path is not longer connected, is not longer available. So this is the, this is disadvantage of configuring summarization. Fine. Apart from it, to reduce this stuck in active state, we can disable active timer as well. But if you disable active timer, which means that now EIGRP will never announce itself in stuck in active state. But if it is not announcing in stuck in active state, then what type of problem can occur? Like routers will always keep that prefix in their routing table. However, that path will not be longer available because router has sent query message, it is not getting reply. So now router will keep prefix in its routing table till it gets a reply packet, right? Because it is not getting reply, so it will always keep that prefix available in its routing table. But yes, if you disable if you disable this active timer, at least your EIGRP is not gonna to break its neighborship with its neighbors, because it will never announce itself in stuck in active state. But this is not a recommended solution. This is never recommended actually to disable your active timer, because if you disable active timer, a big problem can occur in your network, because routers will still keep a bogus information in their routing table. Hope you understood it. And final solution is stub routing, that is most useful. Stub routing. You know, in our network there will be some edge routers. Like for an example, if you are having this kind of diagram, R1, this is R2, this is R3. These two routers are interconnected. Then we are having R4, R5, R6. There was a successor on R1, went down. It will send query to this, it will send to this, it will send to this, send to this. No one will give reply because R2 itself was getting that information from R1 itself, and now it will receive query. R2 will forward that query to its all other neighbors, and its neighbors will keep on to forward that query to their neighbors. So that query will just keep on to moving in your network. I know very well that these routers like R4, R5 and R6, these are edge routers in our network. These are edge routers. You can also call them stub routers. And we know very well that edge routers will never be having any information about prefixes. So what can we do? In EIGRP we can define all these edge routers like R4, R5, R6 as a stub router. Stub. Once we will define all these routers, all these three routers as a stub router, now R2 will come to know that these three neighbors are stub neighbors. Now there is a rule in EIGRP that if it is having any EIGRP neighbor, and if that neighbor is configured as a stub router, then it will never forward any query message towards that neighbor. So this time if you have configured R4, R5 and R6 as a stub routers, then R2 is not going to forward any query packet in the direction of R4 and R5 and R6, because R2 has already came to know that okay, these routers are the stub routers. They don't have any information about any prefix, right? Similarly, for R3 will also come to know that okay, R4, R5 and R6 they are not having any information. So R3 will also not forward any query packet in the direction of R4, R5 and R6. So whenever R1 will receive a query coming from R1, so R2 will forward that query towards R3, but R3 cannot forward that query in the direction of R4, R5, R6. Similarly, R2 will not forward a copy of that query packet in the direction of R4, R5 and R6. Now whenever R3 will receive this query coming from R2, then R3 knows very well that it cannot forward this query in the direction of R4, R5, R6. So what will it do? It will search about that prefix in its own topology table. If it doesn't have any information about that prefix, it will give a reply packet back to R2 with a negative response that I don't have any information about this, right? So now R2 can forward this reply back to R1 that okay, we don't have any information about this prefix. So this time there will not be any problem related to stuck in active. And especially this feature will be in use in case of dynamic VPN, because this kind of topology will be configured in dynamic VPN. Like in dynamic VPN we will be having a hub, and then it will be connected with ISP. Then we will be having multiple spokes. Spoke 1 will be connected with ISP, spoke 2 will be connected with this ISP, spoke 3 will be connected with ISP. We can also have dual hub for redundancy purpose. These hubs will be interconnected, and then you understand, multiple internet connections. This is the same topology, exactly same that I explained you previously. Behind hub, now if anything goes down, then those devices will forward a query packet towards hub. Hub will forward them towards spoke. Spoke will forward them towards another hub. They will simply keep on to send query to each other. Now in DMVPN it is really recommended to configure all these spokes as a stub router. Stub. So now these hub routers will never forward any query packet towards spokes. So in terms of designing, you will be using this stub routing in case if you are having topology in terms of hub and spoke. So on all, you will always define your spokes as a stub router, because you know very well, of course, spokes will never be having any information about any prefix, because all those devices will be edge devices. Fine. So now I'm going to tell you that how can you configure stub routing. And one more thing. Let's say that this is router 1, this is router 2, and this is router 3. I configured this router 3 as a stub. Once I'll configure this R3 as a stub router, now R1 cannot forward query, no, query, no. They cannot forward query now towards stub router. Second thing, if stub router receive any update coming from any one of the neighbor, it will never forward that update towards any other neighbor. Means if stub router receives any update from one of the neighbor, it will never forward that update towards any other neighbor, because it has become now stub. It is not transit. If it is a transit device, then only it will receive update from one neighbor and will forward towards another neighbor. But this time, because we manually define it as a stub router, so it's not gonna to become as a transit device. Understood? Fine. Let me prove it now. What will I do? I'm gonna delete this connection now. Just to prove this practical, right? And then even I'm gonna remove it as well. Gone. You see, R3 has not broken its neighborship yet. Now it broke. So it waited for its hold down interval. Because in GNS actually interface doesn't go down immediately. If it was a physical device, then of course it would have gone down immediately. Fine, let's move on R2. I've designed this network, see, in case of having spoke only. I'm considering R1 and R3, they are kind of like hub, and this R2 is working as a spoke. So right now you can see onto R1, show IP, EIGRP, neighbors, detail. So it can send everything towards its neighbor, query and everything, right? And you can also see that R1 is receiving all prefixes from its neighbor R2, like 30 prefixes. Everything is fine, right? Now I'm going to configure this R2 as a stub. To do it, router EIGRP CCIE, address family IP v4 autonomous system 100. I'll be saying EIGRP. In named mode, you will be configuring this command in this mode. But if it was a classic mode, then the command will be like router EIGRP 200, EIGRP in router mode itself. Done. This time I have defined this R2 as a stub. You can look at R1 now, show IP EIGRP neighbors, detail. What does it mean? Suppressing queries. Which means it is not gonna to forward any query packet towards this neighbor 12.1.2. Hope you understood it.
अपडेट जो जाएगा टाइम पास अगर मैं सप्लाई सर्विस
कहाँ?
R1 पे घाटी नहीं।
अब रुक जाओ, बता रहा हूँ बस, अब एक मिनट रुको, सारा कुछ बता रहा हूँ ये. So what does it mean that suppressing queries, which means that it is not gonna to forward any query packet towards this neighbor, and it can receive only connected and summary address configured on that neighbor. See, what does it mean? Stub peer advertising routes. Which routes? Connected and summary. Which means now stub router can advertise only connected and summary routes towards me. So was R2 having any connected prefix? Of course it was having, that was 23's prefix. So this time R1 must receive only one prefix, that is 23's network, because this 23's network is directly connected to R2. But we didn't configure any summary address onto R2. We didn't configure any summary address. That is why this R1 is not receiving any summary address, right? But apart from that, like we are not having any 30's prefix over here, because this time R2 can advertise only either directly connected or summary. Like for an example, if you want to advertise these 30's prefixes information in the direction of R1, what can I do onto R2? I can move on onto R2's F0 by 0, and then I can say, sorry, router EIGRP CCIE address family IPv4 autonomous system 100 AF interface fast ethernet 0 by 0. I can say some readdress 30.1.0.0.245.248.0. Now I configured some readdress here, and this capability is by default enabled, that it can advertise some readdress. So now onto R1 you must be able to get that some readdress. But but you just simply configure this command like router EIGRP, it was CCIE address family IPv4 autonomous system 100. You simply define EIGRP stub. If you say connected only, if you add this keyword connected, then now even it won't be possible for R2 to advertise that summary address as well, because now it can advertise only and only connected prefixes, not even summary address. So now you can look at R1, you must not get the 30's prefix over here. You are not getting that. And now onto R1 you can configure this command show IP EIGRP neighbors detail.
If R3 is advertising a summary route,
Then
network.
R2 will never come to know that okay, it is a summary address.
Sorry, R3.
Yes, let's say that R3 is advertising a summary address in the direction of R2, but still R2 won't be able to forward that towards another neighbor, because R2 doesn't know that whether it is summarized or normal route. In EIGRP, only on that router where you configure summarization, only that router knows that okay, this is a summary address, right? Apart from that, no one else will come to know that whether this is summarized address or this is a normal network, because within the update it never carries an information like it is a summary address or it is a normal route. It's not like BGP. In BGP, definitely it will always carry forward that information that it is a summarized address, it is an aggregated address. But in EIGRP, this information will never be carried forward within the updates. So R2 will never forward that, because R2 is receiving that update coming from R3. Even we can do that like onto R3 init context router EIGRP CCIE. These problems occurs during lab. They will ask you to configure named mode, and you will be configuring summary address under interface mode, physical interface. So you must be take care, because you are familiar with classic mode. So address family IPv4 autonomous system 100, right? And
Summary.
R2 will receive only summary address this time. Yes. But still it's not, see, for it is a normal route, right? Even AD value is also 90. 5 will be there only on that router where you configure summarization, right? So still you won't be able to get that onto.
No, if we enable the summary, because we have disabled that.
No. Even then also, like router EIGRP, CCIE address family IPv4 autonomous system 100. I can say EIGRP stub and connected and then something. But still it won't be possible for R2 to forward that update, that prefix in the direction of R1. You know why? Because for R2 that prefix is a normal prefix. This summary keyword means if you have configured any summary address onto R2 itself, locally summary address.
Okay.
So you can look at R1 now. There is nothing like summary address.
This was the same statement that you said, like if it will receive any update from its neighbor,
Do show run type session router EIGRP. Let me show you some running config of this. See, you look at R1. We configured that much configuration within EIGRP. So you don't need to remember, or you see, you don't need to memorize the commands. Just look at the running config of EIGRP. If you want to do any configuration within address AF interface default, go there, over here, modify whatever you want. In topology based, copy and paste, modify whatever you want. It's very simple.
Very simple.
To change your k values in address family only, not in topology base, right? Say matrix weights 0 and then k1. Now, like previously, it was required to type all k values if you wanted to modify k values, right? Now it's not like that. Let's say that I just wanted to modify only k1. Type k1, let's say make it 0, done. Only k1 will get changed. Yes, if you wanna modify k6, then you have to type all k values, right? If you wanna modify right? Is there any problem? No. Then neighborship will come up. There is no difference in debug commands. Debug commands are still same as classic mode. Show commands are still same as classic mode. Topology table is still same as classic mode. Neighbor table is still same as classic mode. Everything is same as classic mode. The only difference that they have added some new features in it. They have changed some syntaxes. They have changed metric calculation formula. That's the only thing that they changed in named mode. I would like to say that they have simplified now EIGRP.
ये मैट्रिक वेट के साथ में टोस बिट क्यों है इसमें EIGRP के अंदर?
टॉस यार ये तो मेरे को भी नहीं पता कि क्यों है, बाकी होता 0 ही है, बस इससे ज़्यादा कुछ नहीं होता इसमें.
अच्छा.
But it does not mean that in EIGRP updates it will carry TOS 0. No, it does not contain TOS 0. It takes like it's something like 180 or something like that by default within the IP header. That's different. Within the address family, say matrix weights and then whatever you want, TOS 0, then K1, let's say it's 0, then it will ask for K2, let's say 1, K3, 1, K4, 1, K5, 1, K6. So if you wanna change your K6, then you will require to type all K values.
Okay.
But if you just wanted to change K2, then type up to K2, press enter. It will not show you that your command is incomplete. Previously in older iOSs it was mandatory to type all K values if you wanted to change any single, like if you wanted to change only K1, but it was necessary to type all K values.
Can we also change the key value under the AF interface mode?
No sir. not per neighbor, because formula works globally, not per neighbor, right? नहीं पता सर, मत आओ। नहीं सर, क्यों बताऊं? बता चुका हूं ना पहले क्लास में। हाँ, simultaneously. Okay, yes, that is also possible. They have their backward compatibility, right? If you are running classic mode onto one router, on another router you are running named mode, they can form neighborship, they can work perfectly. There will not be any problem. Like for an example, let's say that on R1, I'm going to remove it now. No router EIGRP, that is CCIE, I've removed it now. And now router EIGRP 100, now assembly network. Oh, I think we configured authentication, right? Let's do one thing from R2. Do show run type section router EIGRP. We have to remove authentication because like classic mode doesn't support HMAC, SHA-HMAC, right? So neighborship, try EIGRP detail. Try it out. Only directly connected, right? But summary is also there because we configured summary address onto R2, right? You can look at this.
But here, if you will change the value of K6, then again there will be the problem with the neighborship.
No, they will not be because they will negotiate it that okay, it supports on up to K5. Stub routing. In stub routing, you are also having some other things like when you say EIGRP stub, as I configured summary connected, along with that you can say receive only as well. But if you use receive only,
Advertising below.
nothing. It can simply receive now. Simply receive. It is not gonna do advertise any single prefix, including directly connected. It is not gonna do advertise anything now. You can look at R1 now and you can see show IP ICRP neighbors detail. Peer is not advertising anything.
सर अगर HMAC यूज कर रहे हैं MD5 की जगह तो बाद में पासवर्ड नहीं चेंज कर सकते?
सर कर सकते हो ना, आप कर सकते हो, दोनों पीएस के बीच में कोई भी पासवर्ड यूज करो, बट रोटेशनल नहीं होगा, वो ऑटोमेटिकली चेंज नहीं होगा, यू हैव टू डू इट मैनुअली. EIGRP stub receive only की जगह पे अब यहाँ पे आप you can use all these all these keywords as well. Like you can say let's say that you perform some redistribution over here onto this device and you want to force this router to advertise redistributed prefixes now towards its neighbors, right? So you can use this redistributed keyword so that it will start to advertise redistributed prefixes. And you see, if you configure redistributed here, connected will come automatically. Do show run pipe section. Let me show you router EIGRP. Connected will appear automatically. Oh, only redistributed, which means yes, no connected actually. In older iOSs actually, if you look at, if you do this configuration in older iOSs and if you call redistributed, connected will appear automatically. So this time If you do not want to advertise directly connected prefixes, you want to advertise only redistributed prefixes, then you can use this keyword, right? Along with that, there is one another option. Along with redistributed, you can also say static. What does it mean? What is the meaning by static? It means that if it was having a static route and you redistributed that static route into EIGRP, then, right? So if you want to advertise that redistributed prefix, however, if you have already taken redistributed keyword, it will start to advertise all redistributed route, whether it was a static route or it was redistributed from BGP or from OSPF into EIGRP. But if you take this static keyword only, let's say that you redistributed BGP into EIGRP, you redistributed static route into EIGRP, but you wanted to advertise only that route which was configured statically onto this router and was redistributed into EIGRP. In that case, you can take this static keyword. And if you take redistributed, then you don't need to use static keyword, because you already said that okay, all redistributed route, because ultimately you have to redistribute a static route into EIGRP, then only EIGRP can advertise that prefix towards its neighbors. That's the meaning by static, right? Fine. Apart from that, you can also configure leak map. Leak map is something like, for an example, I am receiving some prefixes from one of the neighbor, but by default it is not going to advertise them towards any other neighbor. If you want to leak some prefixes between two neighbors, right, then use leak map. Leak map. Just permit some prefixes here. You will call your route map, right? You will have to create a route map. Finally, call that route map under this leak map. Whatever will be permitted in route map, like you will permit some prefixes within the route map. Then, in case if this router receives those prefixes from one of the neighbor, then it will advertise those prefixes towards other neighbors, right? So this is the uses of leak map. Now use all these features with the stub routing as per your requirement.
With the leak map, the behavior of the stub router can get changed.
Routing updates, of course,
So,
to force our stub router to exchange some updates between neighbors, we can use leak map. Finally, and last practical of EIGRP, default route. That how to generate default route, and it's quite simple. In it, we are not having that much complexity as we were having in RIP, like conditional default routing, reliable conditional default routing. All those functions are not available here. In EIGRP, we are having very simple methods. First, let's say R1 is connected with an ISP, then R1 is further connected with R2, R3 and R4, right? We want that R1 should advertise that, let's say that towards ISP you are having a default route. Let's say ISP's next hop address is what? This time I'm just assuming it, right? So we have configured this default route into the direction of an ISP. Now we want that this default route should be advertised into EIGRP. That's very simple. Like first option, route EIGRP. I think we are running here 100, right? Just say redistribute. Fine, done. It's done. Now you can look at R2 and you must get this default route coming from there. Done. Another method, by using summarization. Like we know very well that okay, it is having a static default route towards an ISP. Here this is ISP, right? This portion is ISP. This is hidden, right? And we want that R1 should advertise a default route into the direction of R2. So what can we do onto R1 on its F0 by 0, because it is having a neighbor on this interface, right? And then we can say IP some the address EIGRP 100, and then if we start advertising, then This is another method. Third method, if you do not want to use it, let me remove it, and you will see that R2 will not be having any default route now. Is there? Gateway of last resort is not there, right? Which means default route is not available. On to R1, we can also define an IP default network command. And we know very well that R1 was advertising, like, let's say that R1 is having a prefix interface loop back 10, and it is a class, that should be a classful network, right? 10.1. Then advertise it into EIGRP, and then say, see, right now it is advertising to EIGRP as a normal network, right? Even you can look at R2 as well, it will be received by R2 as a normal network. But if let's say R1 is connected with an ISP, it is having a default route, then I can say IP default network. In its local routing itself, you can look at this. It will get changed. It will start showing you that it is a default network. Oh my god, what is happening here? Clear IP, EIGRP, yes. Do one thing, no router EIGRP 100 and say router EIGRP CCIE IPv4 autonomous system 100 network. Fine. Look at IP route. This is configured as a default network. See, so it is mandatory now, right? Because here on R1 I was using classic mode and default network command was configured in classic mode, but here onto R2 I was using named mode. So it was kind of troubleshooting, like if you are having named mode and EICR, I mean classic mode in a same environment, then you can have this kind of problem. So you have to make sure that you are using either classic mode or named mode in case if you are using this IP default network command. So these three methods are there to create a default route. And what is the advantage of configuring, like this network as a default network? With using this command, I can achieve actually reliable conditional default routing in EIGRP as well. If I'm using this method, IP default network, you know why? Because I configure this route statically over here, right? I said like, I could define this network as this network like IP route 192.168.10.0 255.255.255.0, and then I could say null 0. And along with that, I could use track object. So if it is having reachability with that, till that it will be, this prefix will be available in its routing table, and then I will be using this network as a IP default network. So it will be advertised towards other peers till this route is available in its routing table. And now because we have called track object over here, in case track goes down, it will be removed from its routing table, and now this prefix will not be advertised towards all other neighbors. Just try to understand. Yes, I will redistribute it into EIGRP and then I will define it as a IP default network. Exactly. So
ये तो directly connected है इसलिए
I will remove it. I will remove that loop back. No interface loop back. I have removed it now. You see, show IP route. This is 192.168.1.10.0 towards. You see, show IP route. Let it be. Where is that? Show IP route is static. Okay, track object is not there actually. How to configure track object, then only it will be appear, right? I can remove this track object, do show IP route, you see, and this is the start, which means it is advertised as a default network, right? So further you can redistribute it into EIGRP. So that is the advantage of using this IP default network command. Like I can configure reliable conditional default routing without using route map and all. Fine. So I think that's the end of EIGRP. We do not have anything else now in EIGRP. We have covered all the topics of EIGRP now. And if we skipped anything,